Hello everyone, welcome back. In the last session we were solving the problem number 15 from subject wise test 1 and I explained the procedure to solve the problem. Did you solve the problem? I hope few of you already solved. If you get the answer, that is well and good, but that overall voltage gain will not be 50 into 50 into 50. Your effective gain will be lesser. Here also it will be lesser, but it will be equal to 50 because there is no load. That is what we need to calculate. Okay, let's calculate. It is simply network analysis, right? Therefore now tell me what is your V1? What is your V1? Ultimately we want V0 divided by Vi. That is what is your ultimate voltage gain, effective gain. Therefore now tell me what is your V1? V1 is nothing but potential divider network, right? Ri divided by Ri plus R0 into AV into Vi. Therefore what is your V1? Your V1 is equal to the first one, okay? Is equal to Ri divided by Ri plus R0 into AV into Vi. Therefore what is this? Therefore what is your V1 by Vi? What it may be is equal to Ri is already known to you, which is 1K plus R0 1.25K into AV 50 into Vi. This is what your effective gain. Basically this is your effective gain A star, AV star you can say. Therefore if you calculate what you get, therefore can I say this is KK will be cancelled. 1 by 2.25, 1.25 can I write it as 5 by 4, then it will be 4 by 5, 5 times it will be 40. Therefore what is your effective gain? Your effective gain is 40. Okay, fine. Now second point, I want to know what is V2. Therefore what is V2? Your V2 is equal to again Ri divided by Ri plus R0 into AV into V1. Therefore Ri divided by Ri plus R0 into AV into V1. That is what is your A into V1. I think we already solved it, right? This one we already solved it. Effective gain. Therefore for this also what is your effective gain? Having the load of this, effective gain will be equal to 1K divided by 1.25 into 50 only. Therefore you will get 40 into V1. That is what is your effective gain. Therefore what is this 40 into 40? Because what is V1? 40 Vi. This is nothing but 40 into 40 Vi. Now the last step is nothing but what is your V0? Basically your V0 is nothing but what? Your V0 is, because there is no load. The problem is open circuit voltage gain. Open circuit means there is no load. No load is nothing but V0 is nothing but there is no current. Therefore AV into V2. Your AV into V2. What is AV? AV is nothing but 50 only into V2. But what is V2? We have seen already. Therefore 50 into 40 into 40 into Vi. Therefore this is what is your effective gain. Actually from control systems what will be our gain? 50 into 50 into 50, but strictly speaking is not 50. 50 into 40 into 40. Therefore what is this? If you calculate 5 into 4, 20, 20 into 4, 80, 80 into 10 to the power of 3. Therefore 80,000 into Vi. Therefore that is your V0 by Vi. Therefore your overall gain is nothing but this. This is what? Then if you convert into dB, what is 20 log? 80,000. If you do, what you get? 20 log 80,000 is nothing but 80,000 into 20. 98.06 dB. 98.06 dB. Therefore what is the answer? Surely C. Therefore answer is C. I hope everybody understood, right? Actually it is expected to be what? Instead of 80,000, 50 into 50 into 50. Remember if you put CC buffer, CC amplifier here, which is buffer amplifier, CC amplifier here, which is buffer amplifier, then your gain will be 50 into 50 into 50, because it will avoid the loading effect. Whatever input impedance you have here, that will be avoided. You put CC amplifier, then your load, the load is not affecting your source. Then you will get, instead of 80,000 you will get 1,25,000. Okay, that's fine. After this, write down problem number 16. I'll give you 30 seconds, then we'll see problem number 16. Assuming that the op-amp in the circuit shown below is ideal, then the output voltage is, circuit is okay. This is what is the circuit. Remember, if this ground is not there, it is simply 1 plus R2 by R1, right? See, this is given to confuse you only. Okay, if this ground is not there, it is simply non-inverting amplifier, then 1 plus R2 by R1, 2K by 1K, 2, 1 plus 2, 3, 3 to 1, 3 volt, you will get the answer. But because of this ground, what does it mean? It doesn't have any significance. And this is also not having any significance. There is no feedback. If this is what is ground, can I write this as equivalent like this? Remember, if you overlook the circuit and then think that non-inverting amplifier and then 1 plus R2 by R1, then you will get it. Remember, if this is the circuit, minus plus, then I agree. Without any ground, this is 1 kilo ohm, 2 kilo ohm. Then in this case, what is your V0? V0 is equal to 1 plus R2 by R1 into Vi, therefore 1 plus 2K by 1K, 2K by 1K into 1 volt, you will get 3 volt. But remember, it has ground. If it is having ground, then it is, can I write it like this? Just imagine, this is minus, this is plus, and there is a resistor connected to ground. Now this is what is our 1 volt. Now can I write like this? This is 2 kilo ohm. Can I write like this? This is 1 kilo ohm. This is ideal op amp. Current entering into op amp is 0. Therefore, what is the voltage at this point? The voltage at this point is 0. Because current entering into op amp is 0, there is no drop across 1 kilo ohm. Therefore, here this is 0 volt. And there is no feedback. This is nothing but your load. This is your load. Just load is connected here. Whether load is connected or not there, fine. This is what your output voltage. What is this? This is nothing but your comparator. If this is what is your comparator, which is more? Your minus is 0, plus is 1. Which is more? 1 is more. Then your output will be plus Vsat or plus Vcc. Your V0 will be equal to 12 volt. Therefore, what is the answer? Answer is V0 is equal to 12 volt. That is the answer. Because it is a comparator. Don't be confused. This is nothing but your non-inverting amplifier. Because of the ground which is there, normally typically this is non-inverting amplifier like this. But because of the ground, it is not a non-inverting amplifier. Okay? This is what is your non-inverting amplifier. Okay? I'll give you 30 seconds time. Then after that we will see problem number 17. this 2K between V0 and then ground, V0 and ground, it's a load actually, but represented in that way. Done? Now problem number 17. Consider the constant current source shown in figure. This is constant current source. Okay. Let beta represent the current gain of the transistors. Okay. The load current I0 through RL is, therefore asking for current I0. Circuit is, and this is what is your PNP transistor, and this is what is the load RL, and this is what your op amp. There is a resistor in between, and this is what is connected to this minus and then plus, and it is having G0 diode. This is what is ground, and these are all connected to power supply. This is what is power supply, and his op amp is also having lowest power supply is ground, highest power supply is VCC. This is VCC and this is ground. Okay, this is what is given. This is R2 and R1, and this is what your V reference, and this is what is your, actually this is RN, and this is what your I0. Okay, this is R. Now asking for I0. What is I0? It is op amp problem. First of all, negative feedback or positive feedback? If you don't know, open the loop, okay, to find the feedback, right? When you open the loop, right? Therefore now tell me, let us increase this voltage. When you increase this voltage, remember this is PNP transistor, not NPN transistor. PNP, what it may be? This is what your emitter, this is what your base, this is what is your collector. Okay. Now you take mod VBE, mod VCE and all. Okay. When this voltage is increasing, your emitter is almost connected to power supply, let us say. Then your base voltage is increasing. When base voltage is increasing, what is your VBE? Mod VBE, mod VBE is equal to mod VB minus mod VE. Let us say VE is kept constant, right? When therefore mod VBE, right? Therefore when emitter is almost at constant, when you increase this voltage, what will be your mod VBE? Increases or decreases? It is like your PMOS. Okay, this is what your gate. Source is constant. When gate voltage is increasing, your gate to source voltage will decrease, will increase. You remember I gave you a CMOS inverter. This is what your PMOS. It is something like that. Okay. This is what your gate voltage. When this voltage is increasing, this is, let us say VDD, let us say 5 volt. This is what your VGS, right? This voltage minus this voltage. Okay. Therefore, what is your VGS? Mod VGS is equal to VG minus VS, right? Therefore, VG will be, if you take mod VG mod VS, that is wrong. That's why I gave there. VG minus VS is nothing but 5 volt. Okay. Now it is from 0 to 1, right? 0 volt, 1 volt, 2 volt. As this VG is changing, 0 minus 5, you will get 5 volt mod value. 1 minus 5, 4, 2 minus 5, 3. I am speaking mod. Therefore, when this is what is the value, you will get the values. Okay, 0 minus 5, 1 minus 5, you will get all these things. Therefore, as gate voltage increases, as VG increases, your mod VGS decreases. That is what it is. Okay. Similarly, this is not correct. This is nothing but mod VB minus VE. Okay. Effectively it will decrease. Therefore, your VBE, as base voltage is increasing, this is constant. The delta between V base to emitter, that is what is decreasing. And this is what is decreasing. What will happen? Your VBE decreases. When VBE is decreasing, your IB decreases, IC decreases, IE decreases. When IE is decreasing, the drop across this resistor is decreasing. Then the voltage at this point will increase. And the voltage at this point is increasing. Then voltage at minus is increasing. When voltage at minus is increasing, here it will decrease. Therefore, this is in negative feedback. Okay. Once this is in negative feedback, then remember we can use virtual current concept. When you use virtual current concept, what is virtual current concept? Therefore, this is in negative feedback. If you use virtual current concept, then what is this voltage? The voltage at this point is nothing but VDD out of VCC, Vref is dropped here for VCC minus Vref. That is what you have, because this is nothing but a battery when it is in breakdown. Therefore, it is nothing but reference voltage generator. Therefore, Vref, the same voltage you see here. Therefore, what is the voltage here? This voltage is nothing but VCC minus Vref value. Now, don't touch the original circuit. Now, I am going to original circuit. I don't want to change all these things. Then what is this? This current is nothing but the same current I naught only. Therefore, what is your I naught? Therefore, I naught is nothing but VCC minus the voltage at this terminal, which is nothing but VCC minus Vref divided by R. Therefore, VCC will be cancelled. It is Vref divided by R. That is what is, this is IC, right? This is your IC, collector current. Therefore, this is what is your collector current. Then what is your I naught? I naught is nothing but your emitter current. Your I naught is nothing but your emitter current. What is emitter current? 1 plus, you want I naught, right? What is your emitter current with respect to collector current? Sorry, this is emitter current. For PNP transistor, this is your emitter current, and your I naught is nothing but collector current. This is what is your emitter current, and your I naught is nothing but collector current, right? Therefore, what is the relationship between emitter current to collector current? This is equation 1. We know that IE is equal to IC plus IB. If you do that, you will get 1 plus beta into IB. Then what is your, we want I in terms of IC, right? Therefore, IC plus IC by beta. If you take IC common, you will get 1 plus 1 by beta. Then it is nothing but IC into 1 plus beta by beta. Then what is your IC? Your IC is nothing but in terms of IE is nothing but IE into beta divided by 1 plus beta. This is what is your IC. Therefore, 1 implies what is your I naught? I naught is equal to IE. What is IE? Which you already calculated, which is nothing but Vref divided by R into beta by 1 plus beta. This is the answer. Simply KCL, KVL. What is the answer? Answer is B. Done. I'll give you 1 minute time. Try to do it. Okay, we found negative feedback. Simple. Negative feedback, virtual current concept. Then plus voltage is the same voltage is there. IE we got because that is PNP transistor. Then we are trying to find IC. Got the relation between IC to IE. We got the answer. Done. Now problem number 18. The circuit shown in figure has an ideal op amp. Okay. The oscillation frequency and the condition to sustain the oscillations respectively are asking what is resonant frequency and then condition for resonant frequency. Okay. This is simple. Minus plus. This is your R2 and this is R1, R2. Okay. Capacitor, resistor, 2R. It is not Wien bridge oscillator because Wien bridge oscillator will have RC, but it is different. Okay. Now we need to calculate with the procedure what you know. Beta value and then R. This is R and this is 2C. Right. If you observe clearly, according to Bar-Coulson criteria, this is a non-inverting amplifier. This is what is our non-inverting amplifier. Non-inverting amplifier, where phase shift is equal to 0 degrees and A is equal to 1 plus R2 by R1, R1 by R2. Okay. Here it is R1 R2. Is it R1 R2 or R2 R1? R1 R2 only. Okay. And this is what is your beta network. This is what is your beta network. And let me call this as Z1 and let me call this as Z2 effectively. Okay. Then what is your beta network? It is like this, right? This is what your amplifier. Okay. And this is what your beta network. Then output of this is given to your input. This is your open loop amplifier. Therefore, what is your beta? This is not your V0 and this is not your feedback quantity. Beta is nothing but VF by V0. That is nothing but what you are providing and what are you sampling. Therefore, what is your beta? Beta is nothing but Z2 divided by Z1 plus Z2. If you solve, you will get it. Okay. Therefore, what is Z2? Your Z2 is nothing but 2C, right? 1 by S into 2C. Therefore, 2SC into R divided by 1 plus 2SC plus R. Then 2SC will be cancelled. Then R divided by 1 plus 2 into SCR. This is what is our Z2. Right? Then what is our Z1? Z1 is nothing but 2R plus 1 by SC, which is nothing but 1 plus 2 SCR divided by SC. If you substitute, then you will get beta value. What is beta? Beta is nothing but Z2. Z2 is nothing but R divided by 1 plus 2 SCR divided by Z1. 1 plus 2 SCR divided by SC plus Z2 is nothing but R divided by 1 plus 2 SCR. If you do LCM, then 1 plus 2 SCR will be cancelled. This SC will go there. Therefore, SCR divided by 1 plus 2 SCR whole square plus SCR. If you put S is equal to J omega, then J omega RC divided by A square plus B square, which is nothing but 1 minus 4 omega square R square C square plus 2 AB, 2 2s are 4 plus 1 5. Therefore, J into 5 omega RC. This is what you get. Right? This is real part and this is imaginary part. And we know that according to Bar-Coulson criteria, the total loop phase shift must be equal to 0 degrees. Already your phase shift by non-inverting amplifier, your open loop amplifier, this is 0 degrees. Only when you give 0 degrees or you get from 0 degrees, then only total loop phase shift, which is 0 or multiple of 2 pi, is satisfied. That is true only when the real part is 0, then JJ will be cancelled. Okay. Therefore, to find F0, what is F0? Condition 1 minus 4 omega square R square C square is equal to 0. Then omega square R square C square is equal to 1 by 4. Then omega RC is equal to 1 by 2. Then 2 pi F, right? 2 pi F0 into RC is equal to 1 by 2. Then F0 is equal to 1 by 4 pi RC. Right? But is asking in terms of, therefore, if you write omega only, right? Is asking omega only. Therefore, the resonant frequency is equal to 1 by 2RC. That is what is your resonant frequency. And what is your beta value? And to find beta, what is beta? Beta is equal to at resonant frequency at F0 is nothing but what? 1 by 5, right? Therefore, then what is your A? A is already known. We know that your total loop gain A is equal to 1 plus R1 by R2, and to get sustained oscillations, your A into beta should be equal to 1. Second Barkhausen criteria, the total loop gain must be equal to unity. Then what is your A? A is equal to 1 by beta, which is nothing but it should be 5. 1 plus R1 by R2 should be equal to 5. Then R1 is equal to 4R2. R1 is 4R2. Then 1 by 2RC. Answer is D. You try to observe, you try to solve on your own. I didn't do something, just applied Barkhausen criteria like your what? Wien bridge oscillator. If you want to go to Wien bridge oscillator, you see the procedure, you will get it. But A is already non-inverting amplifier, 0 degree phase shift. Beta, we calculated to get 0 degree phase shift. What is the condition? That condition is giving you resonant frequency, and beta we got at F0. That should be A into beta should be equal to 1. Then A is 4. Then A is 5. Then 1 plus R1 by R2 is 5. Then R1 is equal to 4R2. That is the condition. Then you will get sustained oscillations, not over-damped oscillations, not under-damped oscillations. I will give you 1 minute time, then we will see problem number 19. See, concept is already covered in detail. Okay, done. Problem number 19. The GNR diode in the regulator circuit shown in figure has a GNR voltage of 5.8 volt. And GNR knee current IZ minimum 0.5 milliampere. Maximum load current drawn from the circuit, ensuring proper functioning over the input voltage range from 20 to 30. Therefore, is asking IL max. Circuit is this is 1 kilo ohm, okay, and there is a load which is what is connected here, and this is what your IL, this is what your IZ, and this is what is your VI, and this is what your VZ 5.8 volt. Okay, now what is your IL max? We know the KCL equation, right? What is KCL? And this is nothing but your IS, right? Therefore, your IS is equal to IZ plus IL. And what is your IS? IS is equal to VI minus VZ divided by RS. Okay. 1 implies you want IL, right? IL is equal to IS minus IZ. Then I want IL max. When I say IL max, it should be maximum. Then IS minus IZ maximum. Right? Then IS, because it is having variability, your VI is having variable. I want maximum IS, therefore, then only this will be maximum. IS max, and it should be minimum. IZ minimum. Then how to find IS maximum? IS is already known to you, which is nothing but VI max minus VZ divided by RS minus IZ minimum is given already, 0.5 milliampere. What is VI max? 30 minus 5.8 divided by, what is our, this is 1K, right? Minus 0.5 milli. That's it, I done. What is this? 24.2 milli minus 0.5 milli, which is 23.7 milliampere. Therefore, what is the answer? Your answer is A. I'll give you 30 seconds time. Try to solve. Then we'll see the last problem, problem number 20. Same procedure. Done. Problem number 20. The last problem for the test 1 is, in the figure, D1 is a real silicon PN junction diode. Therefore, V gamma is given, which is 0.7 and Zener breakdown voltage 6.8 volt. Input is a square wave. Then assuming that 10 tau is very much less than T, then what is maximum and minimum? Therefore, what is our output? Max and minimum. Maximum and minimum. That is what is asking. The problem is, remember, this is nothing but a clamper. And this is what is your V0. Diode D1 and Zener diode. Something, and then this is 10 microfarad. And this is what your VI. This is 10 ohm. Some resistance R, doesn't matter for us. And then square wave is given, which is, this is time, this is V, this is 14 volt and then minus 14 volt. And this is what is 0 and then T. Okay. Now indirectly saying that, okay, that's fine. Now let's see. Now apply the input for which diode is on. For what voltage it will be on? For positive voltage. Okay. First one, Pi is equal to 14. Then your diode D is on, but Zener diode will be in breakdown. Therefore, if you do that, you will get, doesn't have, right? This is 0.7 and this is what is your circuit. Then what is your V0 here? This is 0.7 and it will be in breakdown. What is that? 6.8 volt. And now here, this is Vi, which is 14 volt. This is plus, this is minus, this is what your capacitor. Your capacitor will charge immediately. Therefore, what is your V0? Your V0 is 6.8 plus, this is 7.5 volt. Therefore, now your capacitor will be charged to what? Here plus minus 14, and because of this plus minus 7.5, then overall, if you ask me which is more, this is more, plus minus 14 minus 7.5, 6.5. This will be charged. I just applied superposition principle. Okay, fine. Now case 2, for the other phase of the input, Pi is equal minus 14. Surely, this is what is changing suddenly. Voltage across the capacitor cannot change instantaneously. Then then these two will be off. Your diode and both are off. Your diode D is off, but your J0 diode will be is on, but doesn't matter for us. It is open. Then this is the circuit. When I say this is what is your circuit, right? This is C and this is what is R, but C is already charged to what? It is charged to 14 volt. Now what is your VI? Your VI is this minus plus 14. Minus plus 14. Okay. Therefore now what is your V0? At that time. Therefore V0 will be equal to plus minus minus plus. It will be opposite, right? Therefore what will be that voltage? Sorry, it is not 14, it is 6.5. Then this is 6.5. Therefore if you apply KVL, KVL means plus 14 minus 6.5 plus V0 is equal to 0. Then what is your V0? Your V0 will be equal to 7.5. So minus 7.5. Your V0 will be equal to minus 7.5. And here therefore what is the value? What is the answer? Something is wrong. Can anyone tell? When VA is minus 14, right? This is minus, this is plus. Sorry, this is wrong. Okay. That's why answer is not matching. Minus plus minus plus. Then if you do that, it will be plus. Then it will be 20.5. Done. Right? Therefore, what is the answer? Maximum is 7.5. Minimum is minus 20.5. What is the answer? Answer is A. But one point you need to observe is the time constant is very less. The time constant is very less. What does it mean? If you ask me the waveform, it is not like exactly, because time constant is very less, it is violating our requirement of clamping action. But let me show you what will be your output. Okay, this is what your input. Now if your output will be, okay, now when input is 14, your output is 7.5. Fantastic. 7.5. But when input is changing from plus 14 to minus 14, this is plus 14 to minus 14, then it will go to minus 20.5. But immediately it will be coming back. This is what you will get. Immediately it will be coming back. It is disturbing your clamping action. This is what is minus 20.5. He is speaking about max and min. Okay. With this I can say that is done. Maybe you can hold the video for a minute or 2 minutes to understand it. But this is what I think done. Thank you. We will continue in the next session.